Right, now we're going to talk about using derivatives to find rates of change. So we've done examples like this where we have an x-axis and a y-axis and some kind of function, and we've taken a derivative and we've written the derivative f prime of x. One thing we haven't really written the derivative of often is dy dx, and that's where we're going to be focused on writing it this way. And what does this mean if you see dy dx? Well, this is saying the rate of change of y with respect to x. Now, not everything on Earth deals with y and x. Sometimes, and we're going to be using a bunch of real-world examples instead of x and y. So, for example, what if we're talking about like the height of a Ferris wheel with respect to time? The Ferris wheel goes up, it goes down, right? Then I could have some sort of height measurement, I could have some sort of time measurement, and instead of dy dx, we would say dh dt. So these letters here represent the things that I'm comparing. Another really, really good example is in physics. You would often talk about the change of distance with respect to time. So I would say d dt, dd dt, where d would be the distance and t would be the time. And for those of you who have ever driven a car or been in a car before, that's called velocity. So when you're looking at your speedometer, it's usually measured in miles per hour, which is velocity. So you are using calculus when you are in a car and thinking about velocity. Okay, so let's do an example. Okay, you have a hot air balloon and it's inflating, and the volume of the air inside after t minutes is given by this equation. V equals 2t cubed minus 3t squared plus 10t plus 2, and the units are meters cubed. So, and it's inflating between 0 and 8 minutes, okay? So what is the initial volume of air? So whenever they use the word initial, that means we're going to have t equal to 0, okay? So whenever they ask you how is something initially, that's when time is 0. So what I'm going to do is I'm going to take this equation, instead of t, I'm going to put in 0. Okay, so, and when I plug in 0, all of these things are going to become 0, and we're left with 2, and what are the units? 2 meters cubed. That's the volume initially. Okay, now, so the volume was 2 meters cubed. All right, let's do another question. Find the volume after t equals 8. So we haven't done any calculus yet. So, so I've got this equation. I want to find the volume when t equals 8. I'm going to plug in 8 into my equation here. And so 2 times 8 cubed minus 3 times 8 squared plus 10 times 8 plus 2. And I use my calculator and figure that out. And I get 914 meters cubed. Okay, so after 8 minutes, there is 914 meters cubed of air in the balloon. So when you're doing the IB test on these kinds of word problems, they will ask you, and you will be expected to write a sentence explaining what is it that you've done. Not just giving the answer, but writing a sentence saying what it is that you've got. So they might even ask you something like this. What does dV dt, and explain what it means? This is a good kind of question that they might ask on the IB test. So the derivative, so using the power rule, the 3 comes to the front, we end up with 6t squared. The square comes to the front, we end up with 6t, and we've got 10t, that becomes 10. So here's the derivative, and I'm putting the units here. Meters cubed over time, right? So meters over, this is minutes, right? So I'm putting the units here. So, and this is telling us the rate of change in the volume of air after t minutes. So let's answer this last one here. What is the rate of increase of volume at t equals 4? So, so when they're asking for the rate of increase, now I'm going to use my derivative formula and plug in 4 in for t. So I'm going to use my derivative formula, and I'm going to say 6 times 4 squared, oops, minus 6 times 4 plus 10. So, and then after I plug all this into my calculator, I end up with 82. So we got meters cubed over minutes. Okay, and that is our the volume increasing. And since this is positive, that means the air is increasing. It's not losing air, it's increasing air. So basically, the volume increases at this rate at t equals 4. Okay, and that's pretty much it. Watch these notes over if you need extra help.